Welcome to NDAR's GHS webinar series, and today we will address the GHS limit command. Thank you for joining in. Let's get started. It's on the assumption that you have an existing knowledge of GHS, but I'll try to make this webinar as clear and interactive as possible. My name is Stéphane Dardel. I'm a naval architect and I've been using GHS for quite a few years now. The GHS, the limit command is the command that one will use to verify some stability criteria emanating from stability rules and regulations. Okay, the command to define a limit criteria is the command limit, all right, and it will be the actual criteria verification will be triggered by the writing arm command of GHS. On my screen here, I'm showing what would be the typical command sequence to produce stability criteria verification. The first one would be it's an optional one, it would be to define the title for your set of limit criteria, and it is very recommended to do so. A description can be something like IMO A749 intact stability, or US Coast Guard stability, etc., etc. Then you have your sets of limits, eventually a healing moment definition, and then the actual RAH, so writing arm command, with limit attain parameter to trigger the stability criteria verification. Let's now look in more detail at the actual limit command. The limit is the actual name of the command, so your line should start with the command limit, which can be, by the way, abbreviated with the LIM, so lim, instead of writing the full limits. Okay. A limit number, which is optional. If you don't specify it, it will be automatically added by GHS to the next available slot. So if you start with limit, your first limit will be automatically set to limit number 1. Then the type, what type of limit criteria is it? Is it a limit on writing arm, a limit on area ratio, on GM? I will, of course, detail that as we work along. Then there are angles and keywords, which is the actual angle value. So we would be 0, 20 degrees, 30 degrees, or a keyword. And again, I will detail that just next. Then you would have to have an actual equal value. So whether it's a greater than, smaller than, or equal to. And then an actual value. So for example, maximum writing arm should be greater than 0.5 meter. 0.5 would be the actual value to test against. The limit command is very powerful. It's capable to address virtually any regulation, whether an existing one or perhaps a new one that you would be exposed to, knowing that you can fully, as a user, configure your own set of limits. Okay, so a limit can be on an angle, or range of angles. So basically, angle from 0 to 25 degrees of positive stability or something. It can be an angle on area, and area is actually extremely common in any regulation. It's very typical to have an area to check an area limit. You have the notion of energy. So basically, the energy is what you have under the writing arm curve, the restoring energy. Limit can be on an area ratio, and I will of course detail that further along. Of course, area ratio means it's a ratio between the healing area and the writing area, which implies that you have to define a HMMT, so a healing moment, through the command HMMT, which would be the subject of another webinar later. It can be an arm ratio limit. So again, here it requires HMMT, so healing moment, to be defined, and that would be the ratio between the writing arm and the healing arm at a specific angle or for a range of angles. Arm Sine Ratio, it's a specific form of this command where you check the HMMT, so sorry, the healing arm curve against a sine writing arm curve. It's a specific application. Arm-rise limit, so it's a check of checking the actual rise in writing arm between two angles. So if you want to check that between 10 and 20 degrees of heel, for example, the arm has risen by more than 100% or by more than 200%. GM limit, it's also a very typical one, so it's a check of the actual GM, whether at equilibrium or at absolute zero. Float height limits, so it's checking the limit on the float height. Also inclination limits, so you can check also what is your static inclination at equilibrium. Limits are actually described through a range of angles. Okay, so whether it's you're checking an arm, an angle, or an area ratio, it's always through one angle or a range of angles. Okay, and angles may be expressed in absolute values, so angle 0, angle 30 degrees, angle 45 degrees, but can also be expressed as a keyword. And keywords, GHS is extremely powerful in the sense that it proposes many typical keywords that are used and that should address pretty much all regulations. And I will just go through the different ones that are offered by GHS. The first one is max, which is the angle of maximum rating arm. Max 0 would be the angle of maximum absolute rating arm, and the difference here is that the max, this would be the residuary rating arm, so this is basically the rating arm minus the healing arm, which implies that the healing arm, so healing moment had been defined, whereas the max 0 is basically ignoring the healing arm. It's only the absolute rating arm being checked. FLD, flood, this is the angle of downflooding, extremely typical as well. Percentage DI, this is a percentage of deck immersion, and it's actually respecting the margin line that you would have defined in your geometry file. Percentage DI0 would be the angles of the percentage of deck immersion, but this time ignoring the margin line, so it would be to the true physical edge of your deck. Percentage FB, this is the angle of minimum upright freeboard. Okay, so basically the example is if you have a 2 meter freeboard at minimum freeboard upright, then for example adding checking a 50% FB would do a check of the angle happening when at 1 meter residuary freeboard. Equil, this is the angle of equilibrium, known as the first intercept. So this is the first intercept between the writing arm curve and the healing arm curve. And perhaps I will just scroll to the next page, next slide, to just illustrate what it is. That would be your your equilibrium. So this is the intersection between the writing arm curve and the healing arm curve. Step one slide up. Equil 0, this is the angle of equilibrium, but this time disregarding any HMMT. So I will just go to the next page, and this is our equilibrium, so ignoring the healing moment. RA0 will be the angle of vanishing writing arm, known as the second intercept. That would be this intersection here. Again, between writing arm and healing arm. And RA00 is the angle of vanishing absolute writing arm, Here again, we are disregarding the HMMT, so we are looking at this point of equilibrium. This is the angle of pre-roll, and roll is the angle of roll relative to equilibrium. Those two are related to the roll IMO and roll calculation typically used for the severe weather criteria. Okay, so before I go into explaining those in details, I will just come back one up. So I was explaining about angle limits, area ratio limits. Best is that I will go through some worked examples to make it more illustrative. So I will just fire up a GHS screen. And I will read the tanker geometry. Perhaps show a condition graphics window. And what I will do is I will load my model, draft 4, solve for weight and LCG, set a VCG to 5 meter, and perhaps put some load in some tanks. Let's load all the CGC tanks to 0.2. I will do a solve, a status to check the condition, and then perhaps let's work a basic angle limit. Perhaps we can try with limit angle from, let's say, equilibrium to 25. That would be 25 degrees and would be greater than, let's say, 0. And then I can just run my rating arm verification, lim attained. Okay, and obviously the angle from equilibrium to 25 degrees is 25 degrees, so we are in excess of 0, so we get a pass. Okay, and the limit angle can be on more than one terminating angle. So I will just reuse basically the same limit. And note also, by the way, that I didn't specify the limit number, so it attributed automatically the number 1 to it. Okay, let's write another limit, but this time from equilibrium to 25, or let's use DI 0, which would be the deck immersion, disregarding the margin line, and then let's run the same the same rating arm verification. This time we do have two limits, okay, and the fact that we have put the connecting keyword or between the two terminating angles 25 degrees and deck immersion means that it's going to retain the lesser of the two angles. The smaller of the two angles is being retained. Okay, so this is typically a verification on a range of stability. Okay. Then another typical one would be to run a limit on area, and I will just basically copy paste one from my run file here. So this one would be limit number 3, limit area from equilibrium to RA0. So this time we are taking the equilibrium. Let's remember that, let's see, this would be my equilibrium, and RA0 would be this one. So here we will check. So let me just show my GHS window again. we'll check the area between this angle and this angle, and it has to be greater, in this case, to 0.09 meter radians. Then I will just run the same verification, and I I can see that my my area is 1.42 meter radians, so it's in excess of the criteria, so I'm actually passing. Okay, and here again, the limit can be with two terminating angles. Okay, here I'm adding the connecting keyword OR, so here it's going to check between equilibrium and RA0 or flood, and the lesser of the two angles will be taken. And then let's do a rating arm limit, which in this case we'll see that I take that from this reading that the flood is happening before RA0 because I've got a lesser area value, which means that the flood occurs earlier than the RA0, so the angle of vanishing stability. So I mentioned then that after the area limit, we can speak about the area ratio limit, which is again very typical. Area ratio limit implies that you have defined a HMMT, so a healing moment with the command, the GHS command HMMT. And then you have typically two types of area ratio. You have the absolute area ratio, and you have the residuary area ratio. And better than a speech, a sketch would explain that. So you have the plot of your rating arm curve and your healing arm curve here. And the absolute area ratio is taking into account the absolute area below the rating arm curve, which is here labeled area A. And then it's taking the absolute area below the healing arm curve, which is labeled B here. And then it's making the ratio of the two between the angles that you have basically defined. So that would be, in this case, most typically a roll angle up to vanishing stability or downflooding, etc. And then alternatively to the absolute area ratio, you have the residuary area ratio. Residuary because it's taking the actual area below, area under the rating arm curve minus the area under the healing arm curve, again between two angles, in a range of angles. And it's not that one is better than the other, it's just that we are in position with such a feature to address all types of regulations. Some are asking you to check the absolute area ratio, some are actually asking you to check the residuary area ratio. And perhaps better than, I will just show quickly what would be this setup. Okay, let's use the same model, but I will just erase the existing limits. So I would just push limit off. That would erase the existing limits. If I type limit, it will tell me that there are no limits defined in the model. And then I will want to produce a criteria verification on area ratio, both absolute and residuary. So I need to basically apply a healing moment. I will do that through the wind command. So wind 100 knots. It's probably it's probably a bit strong. Then I will just do a HMMT from wind. And I will expect with that if I do a solve, I should have a residuary heel angle at equilibrium. Indeed, we have 5.05 degrees of heel angle. So if I was to show the condition graphics, we are have this small heel angle, which means that now we can actually produce area ratio verification. I will just copy paste some examples. I will pick up those ones, and I will then explain a bit. So it's just a copy paste here. I've defined 5 limits. The first one is RAR, so it's a residuary arm ratio. So it's the same as area, except we are checking writing arm versus healing arm. In this case, it's at max, so it's at maximum writing arm. It has to be greater than two. So basically, this criteria expects that your writing arm should be twice the value of the healing arm at RA max. Limit number 2 is this is the residual ratio, so residual area ratio from absolute 0. Okay, so absolute 0 mean that it would be the actual upright heel angle, as opposed to the equilibrium heel angle, which is now 5 degrees because of the healing moment. So it's from absolute 0 to RA0, so angle of vanishing stability, the second intercept, and it has to be greater than 1. Then limit number 3 is the ratio. So the fact that we don't specify the residuary ratio means it's checking the absolute ratio from APS0 to RA0. So this is basically the same range of angles. And here, in this case, we are expecting that this absolute ratio should be greater than 1.4. Limit number 4 is pretty much the same, except here we are checking all the way to not RA0, which is the second intercept, but to RA00, which is the point of intersection of the writing arm curve, sorry, this blue curve, with 0. So this is the absolute writing arm 0. Okay, it's something that we've met in some recent regulations, like Noble Denton Transport, I believe, that we did implement it to address some recent regulation developments. The last one, this is the so limit number 5. This is the residual ratio from absolute 0 to absolute 50 or RA0. Here the idea is to show that you can have two terminating angles, and having the OR keyword means that it will take the lesser of the two, so absolute 50 or RA0, whichever occurs first. Let's do that. What I'll do is we'll write that into a report, just so that we have a graphical representation. Let's do RA check. Let's call it limit check rather. And then I will do my writing arm with criteria verification. And I will just show a display of the actual report, close and preview. The paper report will look like that. So first page would be the actual writing arm table and the verification at the bottom. And then the next page would be the graphical representation with the actual writing arm, healing arm, and of course we can, then writing area and healing area, which are the quantities under each one of the two curves, and eventually the 4-point height. And then I will just come back one step. The verification tells me that the writing arm ratio at maximum writing arm is actually in excess of 2, so it's actually 5.6 times more than the healing arm, so we're of course safe. Residual area ratio from absolute 0 to RA0 is actually, that's very excessive actually. Okay, never mind. So that would be, again, at this stage, perhaps it's better to show what we are talking. Residual area ratio, that would be this ratio here between area B and area A, and the starting angle being absolute 0 and the terminating angle being RA0. And then third one, verification, this is the absolute area ratio. That would be this one. fourth one is pretty much the same, except we go all the way to the absolute RA00. Yeah, what we have called the RA00. So this is this terminating angle here. And last one has basically two terminating angle, absolute 50 and RA0. So I would think that absolute 50 occurs before RA0 because I've got a smaller ratio. And if I check my RA0, would be this one here. So it's occurring at 95. Yeah, it's actually smaller. The value is smaller because your area is probably decreasing here. RA0 is occurring here at 96 degrees. So basically, it's actually stopping the computation at 50. This is why you have a lesser ratio. Yeah. Okay. So you really do have full control on the way you will model the stability criteria you are looking at. Okay. I mentioned. I will just come back in my slideshow. I mentioned other types of limit command of limit types. Arm sine ratio is pretty much the same as the one before, knowing that it will check not against the actual rating arm, but again the sine curve that is, let's say, an approximation of the rating arm curve. But best is to take a look at the help dictionary for further detail on that specific implementation. Unwise limit is basically what I was saying earlier. Perhaps I would have an example available here. I will just show my GHS window again. I will clear the limits again. So I need to close the actual report, which is still being open here. I will just limit off to cancel existing limits, and I will just go and find the angle, the arm rise, and the syntax for it is rise from 10 to 20. So here we are checking that between angle 10 and angle 20 degree of heel, the rating arm will rise by a factor of 2. So 200%. And indeed we are failing because at 10 degrees, perhaps I should cancel. No, doesn't matter. My rating arm at 10 degrees is about 0.087, and at 20 is 0.327, which I would expect it to be valid. I think I would need to disable the wind. And then, right. Okay, I would need to raise in absolute rating. This is absolute rating arm. So at 10 degrees it's 0.21, and at 20 it's 0.492. Yeah, but 200% means I was looking at 100%, but it's actually 200%. So I would have to have at least 0.6 meter. Okay, so just to mention the arm rise limit, there's of course a possibility to check the GM also, which is very typical. I will just copy paste it from a typical intact stability code. That would be this one. The limit GM upright has to be greater than 0.15 meter. If I just do this one, it's just checking this. You see also that is used the next slot available, which was 1. So limit 1 is the GM upright, and it kept limit 6 as the one that I defined earlier. And then you have limits on the flood heights as well. Perhaps I can just let me try to perhaps copy paste an example. Limit on flood height. That would be a limit flood height at, for example, at 20 degrees has to be greater than the height, so let's say 1 meter in this case. Let's try to check that. Flood height at 20 degrees has to be greater than 1, and we actually have 3.8. So our lowest downflooding point is 3.8 meter above water plane at this position, so we are safe. Okay, and then you also have a limit on that's basically limit on inclination. So the notion of inclination is that it's actually checking. I'm just trying to find an example to provide. Limit inclination at let's try limit inclination at 10. But it's gonna be. I think I will re-implement the healing moment, HMMT wind, and I will try to put the limit incline at let's say at maximum rating arm, for example, has to be greater than let's say it would be, sorry, it would in this case would mean to be smaller than, let's say, 10 degrees. And then rating arm verification. Okay, so the inclination angle at maximum rating arm should be smaller than 10, but it is actually 46 degrees. I don't think I'm being very realistic here, but it's just to showcase what you can do with inclination. But yeah, it doesn't really make sense to check an inclination on maximum rating arm, so sorry for that, but the idea was to just illustrate this possibility. Okay, so that's what you do in terms of limit verification. Again, if I may summarize: angles, area ratio, arm sine ratio, arm rise, GM limits, flood height, inclination. And then I mentioned earlier all the keywords that are available. And well, those are just a mention about the connecting keyword that I was mentioning earlier. And here again, I would invite you to look at carefully at what the limit help dictionary is providing, because those keywords may be contextual. So depending if you are checking an area or an angle, they may change their behavior. So please be careful reading through the manual. But essentially, the 6 connecting keywords that are available are at, from, to, or, between, and end. And the one I was mentioning, which is quite common, it's well, from and to are pretty obvious. So from equilibrium to 30 degrees. And the keyword or is basically checking the lesser of the two. Well, actually, in the case, that's why I was saying it can be contextual. In the case of a limit on the rating arm, the or would take the greater of the two angles. In the case of an area, it would take the lesser. But perhaps better than a word, I will just illustrate that through an example. I will again erase existing limits, lim off, and I will just copy paste 2 limits. This one. Sorry. And then this one. So what we notice is that the first one is checking rating arm at max or 33, and this one is at max to 33. Let's do the check. And basically what we see here is that well, we can see that 33 degrees it would occur here. It's actually 33. It's relative to the starting point. Starting point being 5 degrees. Our 33 is this one here. So it's actually 33 plus 5, so 38. We have a rating arm of 1.078. Okay, whereas the maximum rating arm occurs here at 46.6 degrees, 1.176. So the first limit is actually taking, or it's actually taking the greater of the two angles, whereas here it's taking the lesser of the two. Max array 33 degrees is actually taking the lesser of the two, which is in this case 33 degrees. That's why the or and to keywords are contextual. And in the case of a writing and verification, in the case of an angle verification, it's kind of the opposite. I will just copy paste another two, which are limit of the angle from equilibrium to absolute 25 or DI0, so deck immersion. And the other one is terminating angles are absolute 25 or 2 DI0. And let's see what we get here. Here in this case, it's actually taking the 25 degrees. That would be this one here. Okay, so that would be our the angle of so what would be 27. Where am I? From equilibrium to absolute 25, that would be equilibrium. Perhaps what I will do is I will run the same but without HMMT just to make it more clear. So solve. I've got now a heal of 0 because I cancel the healing moment, and then I will just run the same command. So yes, that's probably more clear now. Here it's actually checking the limit number 3 is from equilibrium to absolute 25 or deck immersion, so whatever happens first. And we see that deck immersion occurs at 32.7 degrees, so 25 degrees is retained. And in this case, it's taking the greater of the two, which is deck immersion, so 32.7. So the to and or keyword, connecting keywords, have a very large influence on the on this. Okay, so that's it for a general overview of the limit command. Yes, so there are some further examples here. Limit angles from equilibrium to or at between. So this is RAR. This is the residual. So yes, the arm-rise limit. Okay. This is a typical set that you would have. I mentioned earlier that it's very indicated to show, to give a title to your limit, so limit title, and then give actual description. In this case, for example, I used IMO A74918 intact stability, and a typical set of limits. Which means also that you would probably write that into a macro command that you can call, because it's very typical to have the coexistence of several criteria within one run file. So for example, you can call your intact stability criteria to run the intact stability, and then do a limit off and call for your damage stability criteria. And final word. It's just let's say an advanced use of the limit and the writing and verification. Why don't you try to interrogate your model by using system variables? There are 3 system variables that may be of interest. The first 2 are lim_num and lim_marg, and the third one is lim_at10. Okay, and I will just explain briefly. The lim_num is basically the number of the limit, which is the most critical one. So if you have a set of 6 limits, when you run the writing and verification, it will retain and it will assign to lim_num the value of the most critical limit of the set of 6. And the lim_marg is for that limit. So let's assume it's limit number 1. It's going to take the margin of your limit. So if you're passing, the margin will be positive, and you will you will be able to interrogate what is the actual margin. So how much margin do I have, a safety margin? And if it's negative, it means that one of your criteria is failing. So it's also a possibility to write, for example, a warning message on the screen, or to trigger another run file, or to trigger another command that will just prompt the user that the ship is failing stability or whatever. Okay, so positive or negative margin. And the third one is also interesting. It's a user variable that you need to declare. and it will basically output what is the attained limit, the attained value for each limit. So if again, if you've got 6 limits, you can declare limit at 1, limit at 2, limit at 3, up to limit at 6, and then that can be interrogated. So basically the sequence would be define your limit, like we've seen until now, then declare, so it's limit number 1, declare a variable that you call lim at 1, and it has to have this name. Then you would run your writing arm verification. Sorry about this typo. And then when you do that, it will of course assign values to those variables, then which means that you can interrogate by using the command note or the command message. You can interrogate that and write that into your report, into your the print file. So for example, I will write the message critical limit is limit, so 1, 2, 3, 4, or 6. Corresponding list margin is such value. And then attained value limit 1 is limit attained 1. So you can actually work out that. So for example, it's something I use when I produce some summary tables for my report. So I try to do the writing arm in the background. So it's not printed to the run file, to the print file. Sorry, it's only producing those outputs that I write in a summary table and on the first page of my report to make it a clear and a concise report. Okay, so that's it. Again, make sure whenever you work with limits to experience is paramount, and try and test this is paramount, and of course check the help manual, because a lot of explanations are provided there, and it's always very important to check, and also it's always important also to make sense out of the output. So whenever you look at your own work, it's important to take the time to interrogate and to, let's say, to make sense out of all the figures that are presented in the report, and confront them to perhaps to your table here, and also to your graphical page, which would show only the report. Okay, and of course, we are at your disposal for any question, so you should know where to find us, ndar@ndar.com. And you can also seek support directly with Creative Systems, the makers of GHS. So I'll thank you for your attention, and I hope this was instructive. Some further webinars will be held soon. The next one is set to occur towards the end of August, and a calendar of the next webinars will be made available soon. And those webinars will address many different aspects of GHS in terms of modeling, in terms of analysis, stuff like HMMT, so healing moment, or stability, or critical points, or tank types, or multi-body feature will be exposed and presented in our next webinars, which will be paying webinars. This one was, as an introductory offer, was made for free. Okay, so again, thank you for your attention, and I wish you a good day, and I hope to talk to you about GHS soon enough. Thank you, bye-bye.